Good morning, good afternoon, everybody. Depends on where you are. João Sousa from Paques Biomaterials. So we joined the ReBioCycle project some time ago, near a CBE funded project, and where we are looking into basically alternative routes for recycling the biodegradable bioplastics in this case. And within this, so we have dived deeper and deeper into this topic.
No.
I see somebody's not muted. So the interesting thing about microbial recycling is a new pathway that is offered by these new materials, but it's several times overlooked also in the routes that are chosen. So it's a little bit what we're going to talk today. So focus first, what are the biodegradable bioplastics? Of course, we have different types of bioplastics as they are classified. Here we are going to focus on the biodegradable ones, and to be honest, most in depth we go into the also bio-based and biodegradable polymers, and the reason is because they fit better with the microbial recycling pathway, because you need to still produce them from bio-based building blocks in the end. So, and this is why it's focused on this quadrant of the classification. So why is this important for us? Of course, we are aiming at bringing a type of PHA into the market, and we talk a lot about product producers, but also end users, and it always comes to myths about the plastics. One thing is, of course, well, it's biodegradable, it will degrade in time, which is not really true. It is biodegradable plastics are not recyclable. They contaminate other wastes, and of course, the only way to get rid of it is landfill or incineration. So these are comments we hear very, very often from people that are outside of this group of expertise, and this really hurts. And we start wondering why so much resistance? Where is this coming from? And of course, it's all about, I think, misinformation. We know that this type of plastics, well, it's not that if they are on your desk, if they start to degrade in time, that's not true. So they will keep there for a very long time until it comes to an environment where biodegradation is taking place. Also sorting, it has now been shown several times, and we keep on doing trials to show it again, and even with more detail, that this type of materials can be sorted in existing equipment. So that's also good for people to understand. And also technically, well, these plastics can also be recycled as others, like you can adopt several routes like chemical recycling if you want to. So it's just about creating the options and developing them technically, and all of them are already there. And of course, the nice thing about biodegradable bioplastics is there are new routes to consider recycling, and that's where the microbial recycling route comes in. So if we come to how usually people look to the recycling of polymers, of course, we have to the reuse. And as I mentioned, well, a biodegradable plastic can be perfectly reused. So you can design it for reuse. You don't need to focus always on the biodegradation, so only a single use application, because it will remain useful for a long time if it's not in the dirty environment, let's say, where microbial activity will take place. Mechanical recycling, also feasible. Of course, some polymers are better than others, but that's the same thing with regular polymers. Some polymers are easier to do mechanical recycling with, others are almost impossible. So here, again, no big difference between these materials. Advanced recycling, which we are going to discuss a little bit. So that's where we have a lot of the chemical recycling, in which you go back into the building blocks to start making up your polymer again. Then you have organic recycling, which is more bringing these new biodegradable polymers back into the biomass route in general, together with other compost streams, via the compost stream, let's say. And then you have energy recovery, which would be really the end of life, either by incineration, but also via the digestion and biogas production, for example. So where does microbial recycling fit? Well, in my view, it does fit better with the advanced recycling route. So industry only sees chemical recycling here, but of course, think about the microbial recycling. It's about bringing down a polymer back into building blocks that you can make a new material that is basically the same quality as virgin material. This is exactly what the microbial recycling route does. So it would be good to see how we can increase a little bit of awareness that this is also part of these options. So how to implement in reality the microbial recycling and thinking about how can we implement it in a way that it's easy to implement in a lot of different locations with more straightforward technologies. That's where we like to introduce this combination with the mixed cultures robustness. And just thinking about the parallel to what happened and what's happening today. So today, basically, we have all these carbon streams, carbon-rich, organic carbon-rich streams. Is it water? Is it solid? Doesn't matter. But they are all full of carbon, and they are being valorized in anaerobic plants, for example, digesters, anaerobic treatment of wastewater to produce, for example, biogas. That's the main product that is being recovered from all these streams at the moment, whatever they are. So basically, what we can see is a parallel to a technology that is already implemented several years ago and is actually widespread all over the world with these type of systems. So if you look to what's happening there, so biodegradable plastics are more than organic carbon source. It's an organic carbon source that we can make use of. And if you would put this in a digester, what would happen? Well, it would be degraded into the monomers, maybe the sugars, then organic acids coming from there, the short chain carboxylic acids. And these would then be converted to biogas, to methane that we can use for energy. So you can actually pick up the same platform, so you don't need to change too much. You change a little bit how you do this conversion to the sugars and the short chain carboxylic acids. And you can actually, instead of biogas, start producing a lot of other materials. You can produce PLA. So basically, you can have your organics being all converted to mostly lactic acid. So there's companies working on it, like Nature's Principles, Triple W, for example. They are working on these ideas on converting waste streams to lactic acid, and it could be also the biodegradable plastics, and then polymerize this lactic acid into PLA. Then we have the case of the PHA, while we are working on, you can do the same route. You go to the anaerobic way of producing the short chain carboxylic acids that you can then use for a microbial polymerization into PHA production. Also, another example could be PBS. It's not very explored at the moment, but we know that with organic streams, there are groups working on, for example, BDO, butanediol production, and also succinic acid. So you could have these both being produced in this way and then being polymerized. So there's a lot of possibilities on these type of routes by using the first step as very similar to a widespread technology that is being used today. So meaning that we fit into even maybe existing infrastructure that is already out there. Of course, some biodegradable plastics are easier to degrade. Some are a bit slower and maybe need a push. So it is also considerable that you might have to use some hydrolysis methods used on temperature, for example, or chemical additions. But you can also think about combinations of having a little bit of a physical chemical treatment before going into the biological recycle. So it's a combination of two steps. And this is also being done again to these organic streams today. So it's nothing new in this field. So it's more about how can we pick up this existing infrastructure and knowledge on this type of conversions, anaerobic conversions, put them into using the biodegradable bioplastics as the feed source. So it's basically converting this knowledge. From now on in this talk, to be honest, I'll focus a little bit more on the PHA part, and that's also because that's where my expertise lie. And is also one of the ones that allow a full microbial step towards the end product, but it doesn't mean that similar concepts could not be applied for the other polymers. Now going to one of the first options. So that's something that is also being evaluated in the ReBioCycle. And the goal is, of course, you have the PHA products being used, then they end up in the plastic waste, which is sorted. Then you get a sorted PHA out, and then you ferment this PHA back into short chain carboxylic acids. The question is how you can do this fermentation good, because of course PHA is biodegradable, but fermentation might take time, so it's all about how can you speed it up. And then, of course, from here, from these acids, the short-chain carboxylic acid, you can produce, again, new PHA and produce new products. And actually, the nice thing is the PHA you produce is basically virgin quality. You are going back to the building blocks and building it from there, so you'll get the same quality in the end. And it is also, if you use this type of routes, it's also possible to use a bit of contamination, I think, because you are really going into, if you have a bit of contamination, for example, I mean with the organic streams, for example, if the plastic is not well washed, let's say, well, the organics present in the PHA will not really hurt the recycling route. On the downside, of course, you have to do sorting, so that always leads to losses, both at the households and both at the sorting lines. Of course, you minimize them as much as you can, but there's always some losses. And of course, you are limited by the biological yield, which is somewhere between 25 and 40% on COD, which is the measurement for organic carbon that we use. Which, yeah, it's very hard to break free from these limits because they're biological limits, unless we come up with new interesting solutions for PHA production. Then we can consider another route, and that's something that it was started research in Wageningen University here in the Netherlands, and we are also now connected to this research. And basically their idea is, well, you can have PHA sorting, but you can also avoid the sorting, and you can let it go with the organic waste. So if it goes with the organic waste, you basically, you are processing everything together. You need to do some hydrolysis, because, well, also for the organic waste to be converted, it is better to do a bit of hydrolysis to convert to come to the short chain carboxylic acids. You get better yields, so you have to implement that. But again, you come to the short chain carboxylic acids, you can start the whole virgin PHA production route again, even though you come from these contaminated streams. So you can process two organic streams together and still end up with a virgin type of material in the end. Disadvantages, well, similar on the biological yield, and also in this case, a little bit on the quality side. So you have to deal with the variability of the organic waste composition. So organic waste, we've played with it for a very long time, and we see that mainly in the year cycle, there's considerable changes in the type of organic waste that is received, depending on season, where you are, and depending on the weather conditions also makes a difference. It's really interesting to see these dynamics, but they pose a challenge for quality control. Not impossible, but something that would need to be worked with. But it is something to think of, that we need to account for this variability. Then we go to another idea, and that's also explored in the ReBioCycle project, in which we put some extra treatment in line, and that's where Torwash, our partners within ReBioCycle, come in. And there's also been work done again in Wageningen University, and there's a PhD thesis published on this topic also, which is we start with the bioplastics as a mix. So they can be as a mix or sorted. You can decide how much you go to, if you really need to sort completely the different plastics or not. But then what you do is a hydrothermal treatment to be able to break down the PHAs in a thermal way to the building blocks and to acids, basically, that you can then use again to produce the short chain carboxylic acids and go back into virgin PHA production quality. The nice thing here is we can also mix certain bioplastics are a bit harder to biodegrade. Imagine PLA, of course, we all know that you need to reach a high temperature to be able to really start to degrade PLA well. So in this case, you can put this kind of materials also in the same recycling route. Disadvantages again, sorting, less than before, but still you might have some losses with sorting. And of course, the biological yield keeps on being one thing, and you'll see. I'm always putting it here, but it makes sense in the end. So these are very broad routes that we could choose for. But when you start talking to different industries, you also start to identify niches where there could be even more synergy within a certain industry to use these microbial recycling routes. And this is one that we identified with the paper industry. So we have been focusing on the paper industry for a long time, talking with mills that recycle paper, because their process water is actually very suitable for PHA production. This is actually where we are planning our first. And if you look into the paper industry, there's a very nice potential synergy there. So if we use the process water of a paper mill, it is rich in organic matter. And the reason is because paper, it's not only cellulose, around 10% of paper is actually starch. And this starch in the repulping process actually gets hydrolyzed and ends up in the process water and needs to be removed. So either companies, even if they discharge or reuse the water, they always have to remove this carbon. They have to treat it. So what we do is we remove this carbon by bacteria that produce the PHA. So we produce PHA at the same time. And of course, you can use PHA with paper. So you can use it as a paper coating. You can use it as an adhesive for paper. And of course, get it into the products. The nice thing is then you fit into an existing infrastructure of recycling. So for example, you can actually, the paper recycling route is one of the most developed ones and efficient. So basically, you recycle the paper using an existing infrastructure, goes back into the recycling mill, and there are two things can happen. PHA gets hydrolyzed, and then it ends up in the process water as carbon, usable carbon again, so you can make new PHA out of it. Or, of course, it ends up in the paper without hurting too much the properties of the paper. So the nice thing about this is, sorry, I moved this skip, but the thing about this is there's a lot of synergy. You enter an existing infrastructure, and actually you solve a plastic issue in an industry. So actually the paper industry has a lot of problems with plastics at the moment because plastic use in paper is growing considerably. So they have a lot of paper waste, plastic waste actually coming from the factories that has to be dealt with. Some of them have their own incineration plants, for example, to deal with this. So it is just an example how now we could get into an existing industry and get more synergy in the whole cycle of recycling. Just for information, this is something that we really try to happen. So we hope to start building this plant this year. So we are close to finalizing the investment decision. This will be our first PHA production plant, and it will be exactly with ESCA, paperboard producer here in the Netherlands. So we hope that we can start showing this type of concepts soon. So wrapping up, so there's a lot of ways you can think about microbial recycling. I mentioned some. It doesn't mean that that's all. So I hope more options become available. And that's also where we come. All of them have pros and cons. So there's no perfect route. So we have to choose the best route for a certain situation. Also depends on where we do it. What kind of infrastructure do we have in a certain country or a certain region? What are the whole sorting and actually recycling paths that are happening in those regions? So we need to try to come up with a nice comparison, nice overview of whatever technologies are there on recycling, including the microbial recycling for this new type of polymers, to really start being able to make good decisions. So I make here a very simple start of this, but of course there's way more information required. I think there's way more routes that we can think of and detailing, but this is something that I would like also that these 3 European projects that contribute to this new recycling methods for biodegradable bioplastics, that they really try to fill in this matrix, this table of information that we can use to select the best route for a certain region or a certain material even. So yeah, I hope that soon we get more information on this, and well, I'm open to questions, comments from your side.